Hi everyone, today we are going to solve the left questions of our exercise 3.5. So let us see our question number 5. In which of the following expressions prime factorization has been done? We know that what is prime factorization? The prime factorization means in which we are breaking the numbers into small factors and the factors all are a prime and each factor is a prime number only. So 24 is equal to 2 multiply 3 multiply 4. We know that in prime factorization all the factors which we get are all our prime number only. But here you can see that 2 and 3 are prime number but 4 is not a prime. Since 4 is a composite number, hence here prime factorization has not been done. How can you say that prime factorization has been not done? As we know that in prime factorization, as we do prime, all numbers should be prime only, but here 4 is a composite, so prime factorization has not been done here. Second one, 56 is equal to 7 multiply 2 multiply 2 multiply 2. Here prime factorization has been done, or you can see like this: 56, 2, 2s are 4, 2 8s are 16, again 2 1s are 2, 2 4s are 8, then 2 7s are 14, 7 1s are 7, means 2 multiply 2 multiply 2 multiply 7. Here you can see that since all factors are prime here, 2 and 7 both are prime number, so hence we can say that here prime factorization has been done. Third one, 70 is equal to 2 multiply 5 multiply 7. Only you have to see that the factors which are given here are prime or not, and you can see here 2, 5 and 7 all the factors are prime, therefore we can say that hence prime factorization has been done here. Fourth one, 2 multiply 54 is equal to 2 multiply 3 multiply 9. Here 2 and 3 are prime number, but we know that 9 is a composite number. Since 9 is a composite, hence we can say that here prime factorization has not been done, because in prime factorization all the factors should be prime only. Now question number 6. Find the prime factors of 105. Arrange the prime factors in ascending order and find the relation between two consecutive prime factor. So first we have to find the prime factors of 105. It means we have to find prime factorization. As you can see that here 105 is a odd number, so it is not divisible by 2. So we'll check it by 3. So 3 3s are 9 and 10 minus 9 1, means 1 and 5 15, and 3 5s are 15. 3 3s are 9, 1 is left, means 3 5s are 15, 35 times. Then 35 is divisible by 5, so we'll take here 5 here. 5 7s are 35, then 7 1s are 7. So 105, its prime factorization is 3 multiply 5 multiply 7. Now we can see that we have the prime factor 3, 5 and 7. After arranging the prime, now we have to arrange in ascending order. So if we arrange in ascending order, we'll get the factors as 3, 5, 7, and find the relation between two consecutive prime factor. Consecutive means one after the other. So after 3, which is the prime factor here, 5, after 5, 7. Now we have to find the relation between them. So we can see that if we minus 3 from 5 and 7 from 5, we'll get the same difference, 2. So 5 minus 3 is equal to 2 and 7 minus 5 is equal to 2. So we can see that the difference is 2. So this is the relation between each consecutive prime factor. Means we have to find the relation between 3 and 5 and 5 and 7. The consecutive means one after the other factors. Now question number 7. Determine if 25,110 is divisible by 45. We have to see that whether this number is divisible by 45 or not. Here we can see that 5 and 9 are co-prime number, and we can test that if a number, this given number 25,110 is divisible by 5 and 9, then we can say that it is also divisible by 45, as this one is the property second of property of divisibility. You know that if a number divisible by two co-prime number, then it is also divisible by the product. Product means by 5 multiply 9 also. So since solution, we can see that 45 is equal to 5 into 9, we can write 5 into 9. So first we will check whether the given number is divisible by 5 or not. So 1 and 5 are factors of 5 and 1, 3, 9 are factors of 9. Factor means 9 is divisible by 1, 3 and 9. So hence we can see that the common factor in 5 and 9 is only 1. Hence 5 and 9 are co-prime number. Now we'll check whether it is divisible by 5 or not. So what is the technique here? Trick here, the last digit of 25,110 is 0. And we know that if the last digit of any number is 0 or 5, then we can say that it is divisible by 5. Now we'll check whether the given number 25,110 is divisible by 9 or not. So for checking for 9, we have to find sum of digit. So sum of digit 2 plus 5 plus 1 plus 1 plus 0, which is equal to 9. Now we'll check whether 9 is divisible by 9 or not. Since the sum of digit of 25,110 is divisible by 9, hence the number is also divisible by 9. Now you can see that since the number is divisible by both 5 and 9, therefore it is also divisible by 45. As we know that this is the property that if a number is divisible by any two co-prime number, then the product. So you can see here that it is divisible by both 5 and 9 co-prime number. So it is also divisible by their product. Product means by their multiplication also by 45. So here you can see that without checking directly by 45, we can check it by 5 and 9. Now we are going to read a new topic, highest common factor. So what is this? The greatest number which is a common factor of two or more given number is called their highest common factor. As we have seen how to find common factor, we have to see the common factor which is common in both 2 or 3 given number. But here we have to see the highest common factor out of all the common factors. Or we can also say that it is a greatest common divisor or greatest common measure. For example, consider the number 16 and 24. So divisors of 16 means the factors of 16 are 1, 2, 4, 8 and 16. It means 16 is divisible by this many number. Same here, divisors of 24. It means 24 is divisible by 1, 2, 3, 4, 6, 8, 12 and 24. Now all common divisors of, which are the common divisors here? 1, then 2. After this, the common divisors are 1, 2, then 4 and 8. And the greatest of, now we have to see the greatest divisor here. Out of 1, 2, 4 and 8, the greatest digit is 8. It means the greatest of this number is 8, or we can say that the highest common factor of 16 and 24 is 8. Here 1, 2, 4 and 8 are common factor, but we have to see the highest one, and highest one is 8. Therefore the highest common factor of 16 and 24 is 8. This is the common method which we are using by factorization. First we'll find the factors of the given number. After that we'll find the highest common factor. Then the highest common factor is we can find by two methods. There are two different types of method. First method is prime factorization and second is continued division method. So first we'll see what is prime factorization method. As we know that how to find prime factorization. So we first find the prime factorization of each of the given numbers, then the product of all common prime factors using the least repetition of each common prime factor, that is the HCF of given number. So let us see by one example. Find highest common factor of 36 and 84. So first step is to find the prime factorization of each given number. So first we'll find the prime factorization of 36. So 36 an even number, it means it is divisible by 2. So 2 ones are 2, then 3 minus 2, 1 is left, it means it is 16, and 2 8s are 16 here. Again 2 9s are 18, then 3 3s are 9, 3 1s are 3. It means these are the prime factors of 36. Same here 84. It is also an even number, it means it is divisible by 2. So 2 4s are 8, 2 2s are 4. Again 2 2s are 4, 2 1s are 2. Now 21 is an odd number, so it is divisible. The next number after 2 is 3. It means it is divisible by 3. So 3 by how many times? 7 times. 3 7s are 21. Then 7 is divided by itself. 7 ones are 7. So these are the prime factors of 84. Now write 36 is equal to 2 multiply 2 multiply 3 multiply 3. Same here 84, 2 multiply 2 multiply 3 multiply 7. So this is the prime factorization of 36 and 84. So now we have to see which are the common factor here. We find that here 2 occurs a common factor at least twice. It means here 2 is a common factor. How many times it is repeating? 2 times in both number. And 3 occurs as a common factor at least once in each of the given number. So we have to see the common factors here. So which are the common factor here? You can see here 2 is given, here also 2, here 2, and 84 also it is 2, then 3 and 3. Now here it is 3 given, but in this 7, it means these are not common. So the common factors are 2 multiply 2 multiply 3. Now multiply this, 3 2s are 6, 6 2s are 12. So highest common factor is 12 here. So you have to see the common factor and after that you have to multiply. Same, now you can see the 3 numbers are given. So first we'll find the prime factorization of each number for 70, 105 and 175. After finding prime factorization, write its factor. 70 is 2 multiply 5 multiply 7, 105 3 multiply 5 multiply 7, and 175 5 multiply 5 multiply 7. Now we have to see the common factor in each of the 3 given number. So you can see that which are the common here. Here you can see 2 is given in 70, but there is no any 2 in 105 and 175. It means it is not a common factor. Now see, 5 is given all 3, it means it is a common. 7 is also given all 3 number. It means the 5 and 7, only 5 and 7 are the common factor in 70, 105 and 175. Therefore the required HCF will be 5 multiply 7, which is equal to 35. So the first method, prime factorization method, first you have to find the prime factorization of each individual number. After that you have to see the common factor in all the given number. So that will be the HCF. Note, we can see that when there is no common factor other than 1 in 2 number, then their highest common factor is 1. If there is no any common factor other than 1, then the HCF we can say that directly it is 1 only. And such numbers are called co-prime numbers, may not necessarily be prime. And that type of numbers are known as co-prime. As we know that the co-prime number means which are having only common factor as a 1. And it is not necessary that the number for which we are getting HCF are prime number only. They can be other composite number also. So the number 64 and 125 are co-prime, whereas none of them is a prime. Here you can see that 64 and 125 are having 1 as a common factor and their HCF is 1. But 64 and 125 both are composite number. Now we'll see second method, continued division method. So let two numbers. This one method as like the simple division as we are doing for finding the answers. So divide the greater of the two numbers by smaller one and the remainder. Next, divide the divisor by the remainder. Go on repeating the process of dividing the preceding divisor by the remainder and last obtain till the remainder is 0. Thus, the last divisor is the required HCF. So let us understand this continued division method by one example. So find the HCF of 32 and 42 by division method. So here you can see, first you have to see the greater number here. Out of 30 and 42, the greater number is 42. So you have to divide the greater of the two number by a smaller one. So here we have to divide 42 by 30. So now you can see that 42 is we have to divide by 30. So 30 ones are 30. Now minus this. So 42 minus 30, 12. Now this divisor which is given here, this will come in place here. It means we have to divide now 30 by 12. Again 12 twos are 24. Now minus 30 minus 24 is equal to 6. Now we have to write Now we have to now this 6, now this divisor 12 will come inside and you have to divide 12 by 6. So 6 2s are 12. 12 minus 12 0. Here we have to continue this process till we did not get the remainder as 0. So you can see that after dividing 12 by 6, here remainder is 0. It means the divisor, the last divisor is the answer of our HCF. So you can see that hence HCF is here 6. This one will be the answer. You have to continue divide that one. This first you have to divide 42 by 30. After that you have to minus. Now this divisor 30 will come inside and you have to divide by 12. Same, if you minus it you will get 6. Now this 12 will come here in place of this dividend. So 6 2s are 12 and you get the answer as 0. So the last divisor is the highest common factor. Hence we can say that highest common factor is here 6. This one question also you can find by prime factorization method also, but here we have to find using continued division method. Now if you want to find the HCF of more than 2 numbers by division method. If more than 2 numbers are given, choose any 2 of them and find their HCF. Now take HCF of 2 numbers and third number again, find their HCF. So that required HCF of 3 numbers. Now we have to repeat the previous step as if we are doing for more than 3 numbers and so on. Now you have to find HCF of 570, 665 and 266. So you can take any 2 number. So first we have taken 266 and 570. Out of this you can say that here 570 is greater than 266. It means we have to divide 570 by 266. So 266 2s are 532. Now minus this. So 10 minus 2 8. 6 minus 3 3. So here 38. Now we have to divide 266 by 38. We know that if we divide 266 by 38 it comes 7 times. Now you can see remainder is 0. It means the HCF of 266 and 570 is 38. Now here the last number 665 is left. Now we have to find, the next step is to find the HCF of 38 and 665. We have to find the HCF of third number with the HCF of this 2 number. So find HCF of 38 and 665. So here greater number is 665. It means we have to divide it by 38. So first we will take 38 ones are 38. Now minus this. So 66 minus 38 which is equal to 28 here. Now 5 will come here 285. Again 38 sevens are 266 and if we minus this it will get the answer as 19. Here we have not taken 285 inside 38 because first we have to divide all the 3 numbers. After dividing only you have to take 38 inside. So you can see that here 665 is completely divisible how many times? 17 times. Now here remainder is 19 and we did not get the remainder as 0. Now this 38 will come in inside and we have to divide 38 by 19 and 19 2s are 38. Now you can see that here remainder is 0. It means our division is over. So the last divisor is 19. So the HCF of 38 and 665 is 19. So hence HCF of 570, 665 and 266 is 19. So this is the way to find highest common factor of more than 2 numbers. Now let us solve question number 1 of our exercise 3.6. So find the HCF of following numbers by prime factorization method. As we have seen before only, in prime factorization method, first you have to find the prime factorization of each number. After that we have to see its common factor. So first one is given 30 and 42. So for 30 it is an even number. It means first we have to divide it by 2. So 2 15s are 30. Then after that we have to take 3. So 3 5s are 15 and 5 1s are 5. We have to find till we get the answer as 1. Same here 42. So 2 2s are 4, 2 1s are 2. Then 21 after 2 it is divisible by 3. So take 3. So 3 7s are 21 and 7 is divisible by itself, so we have to take 7 ones are 7. Now write its factor. So 30 is equal to, here it is given as 2 multiply 3 multiply 5, and 42 is 2 multiply 3 multiply 7. Now we have to see its common factor, the common number which is common in both in 30 and 42. So common factors are 2 and 3. So common factors of 42 and 30 are 30 and 42 are 2 and 3. So HCF is equal to 2 multiply 3, which is equal to 6. Therefore we can say that the highest common factor of 30 and 42 is 6 here. We have to see the number, the factor which is in both 30 and 42, and after that we have to multiply that one. Next one, 24 and 36. Again we'll find the prime factorization. So 2 12s are 24, then 2 6s are 12, 2 3s are, here it will come as 3, 2 3s are 6, and 3 1s are 3. Then 36, 2 18s are 36, 2 1s are 2, 2 8s are 36, then 2 9s are 18, 3 3s are 9, 3 1s are 3. If you do not know how to find it directly, you can here divide also. So 2 1s are 2, 2 8s are 6. Now we have to write factors. So 24 is 2 multiply 2 multiply 2 multiply 3, and 36 is 2 multiply 2 multiply 3 multiply 3. Now we have to see the common numbers here. You can see common are 2, 2 and 3. Here 2 and 3 are different, it means it is not a common factor. So common factors are 2, 2 and 3. So multiply all the three numbers. So 2 multiply 2 multiply 3. So 2 2s are 4, 4 3s are 12. So we can say that the highest common factors of 24 and 36 is 12. Third one, 18 and 16. Again we have to find its prime factorization. So prime factorization means 2 9s are 18, then 9 is divisible by 3, so 3 3s are 9, means how many times we have to write here. Again 3 1s are 3. Then 60, it is an even number, it means it is divisible by 2, and we have to see how many times. So 2 3s are 6 and 0 as it is. Again 2 1s are 2. We know that 30 is divisible by 2. How many times? 15 times. 2 1s are 2. Then 10, 2 5s are 10. So that one answer we have to write here. Again 15 is divisible by 3 how many times? 5 times. So you have to write 5 here. Then 5 is divisible by 5 itself. So 5 1s are 5. Now write its factors. So 18 is 2 multiply 3 multiply 3, and 60 is 2 multiply 2 multiply 3 multiply 5. Now we have to see the common factors here. So which are the common factor here? 2 is in both, then after that 3 is also in both 18 and 16. Then you can see here 3 is given, but here there is no any other 3, and here 5 is given, but 5 is not in 18. It means the common number here only is 2 and 3. So highest common factor is 2 multiply 3, which is equal to 6. Therefore we can say that the highest common factor of 18 and 60 is 6. Then fourth one, 20 and 36. In this question also, first you have to find the prime factorization. After that you have to see the common factor in both 20 and 36. So this one is given you as a homework. Then the remaining questions we will see on the next day of our class.